Hello viewers, uh, this is Satyajit Raham. I have already started to study about the trail analysis. I have already watched two videos, part one, part two. To enable these videos, just search by search videos by Ninian Saha. Then you will get all these videos. These videos to watch is very important to continuation of study of the trail analysis by Ninian Saha. So you will get all these videos and you can easily start your search or YouTube search you can do. So by searching you will have many videos watched by me. You can very easily study or watch and study all these videos as you like. So before starting your trail analysis part 3, I must appeal to all of you to subscribe this channel. And if you like, then like this video and share it with your friends. So let's start now. Now today we will discuss scalar triple product. Scalar triple product. This is a senior level of vector analysis, very important. Scalar triple product. To know such kind of products behavior is very important for physics especially, and mathematics also. Triple product. So you have three vectors A, B, C. You have any three vectors A, B, C, A vector, B vector, and C vector, and they are related with in this way. B vector, A vector dot B vector cross C vector. I have already said that B vector cross C vector always show a area modulus of B vector cross C vector always show a area of a parallelogram. So and because B vector and C vector cross have a sign also, direction also. So magnitude as well as direction, and dot product don't have any direction, but it have a magnitude just. So this form is not square or triple product. Square triple product. So how it is the diagram will be? Now I am again giving you a very clear knowledge about a square triple product. If you will take this is B vector in the direction, the B vector in the direction y-axis, y-axis, and if you take it is C vector, this is C vector in the direction z-axis, then C vector in the direction z-axis. So what will be B cross C? This is anti-clockwise. It will rotate this diagram and bring the x-axis in front, and you will see that this is the anti-clockwise direction. So this will the B cross C, the product will have a direction towards x-axis, and in this direction A vector also is working. Its direction is the same. So A dot B cross C have no direction, just it have a magnitude. So what will be its magnitude? So we know that it will have modulus of A vector, and B vector plus C vector, and between them it will make an angle. So here there is zero angle between them. So there is will be cos zero, which will be 1. Cos 0 it will be 1. Now again if you will do, then vector A, if you will use formula of the cross vector, then it will be modulus of A, modulus of B, and modulus of C vector, and this is already cos 0 is equal to 1. So when you use sine theta, so here theta is pi by 2, so this is also 1. So you are getting A, modulus of A, modulus of B, modulus of C, because sine pi by 2 is 1. So here is the relation that we will get just modulus of A vector, modulus of B vector, and modulus of C vector. This is the triple product. So multiple of the magnitude of the three products which are perpendicular to each other. Here three vectors are perpendicular to each other. If they are not perpendicular, then we will have cosine and sine, of course. But here we have taken that all the vectors are working as a perpendicular. So we have the magnitude value. It's modulus A vector, modulus B vector, modulus C vector. And if the vectors are not working perpendicularly, then we have cos theta and sin j also. Cos theta and sin j also. If just general form will be cos theta, theta is angle between and the A vector and the product of B and C vectors, and sin j will be the angle between B vector and the uh, C vector. So this will be the general form. So it is actually denoted in this way. The scalar triple product is denoted in this way: A vector, B vector, in the third bracket, and C vector. It is denoted by in this way. Now we have also a uh, other property that A vector dot B vector cross C vector cross C vector is equal to B vector cross C vector. You know this region. I have already said that dot product is commutative. The scalar the dot product is commutative, so that's why we can commutate this. So we will get this you can find out very easily by commutative. And one more, this is very important, that it can be also written C vector cross A vector, and vector product is not commutative. Scalar product is commutative, but vector product is not commutative. So C vector is at first and A vector is in second. This order must be remembered. Dot B vector. So this is very easy to understand. This is very easy to understand. Just we are getting from dot product that it is commutative, so it can be written. How this can be found out? So I am giving a diagram to understand this. Here I am taking that all the vectors are working perpendicularly. There are three axes: x axis, y axis, and z axis. So A vector is working here through x axis, y vector through on y axis, B vector is working, and z axis z-axis the c vector is acting. I've already found that we have already found that the scalar triple product, if the vectors are working perpendicularly, then it will be equal to the modulus of the three vector multiplication of the modulus of three vectors. Now, from this it can be found that so c vector cross a vector will take in perpendicularly. Here also in this way C and A, if you take anti-clockwise rotation, then you will get positive direction y-axis, and this will you will get true for if the vectors are working perpendicularly. But for not working perpendicularly, the three vectors, if do not working perpendicularly, then it can be true. If there is another angle, this way, if this vector work, a vector, there is theta angle, p vector, and this is I am taking psi, this is c vector. So here it is true, c cross a, c cross a vector is actually 2 pi minus sine 2 pi minus, and there will be also minus. Actually angle is psi plus theta, so sine psi plus theta. So it is very long to calculate this, but I am just uh, doing a short way to formulate this. C cross A have psi plus theta, so sine psi plus theta, and then with b vector. So it can be proved, but it is very long, so I am not proving this. Just you remember, I will watch another video to prove this. It will be very long. In a short video, it cannot be proved. So I am leaving this for now, and try to watch another video to prove this. So let's go in another topic. IJK are the unit vectors. We know I is a unit vector acting through x-axis, J is a unit vector acting through y-axis, and K is a unit vector acting through z-axis. So what will be their scalar triple product? I vector, J vector, and K vector. If I directly, because they are working perpendicularly, I can write directly that this will be equal to modulus of I vector. I have already proved this, dot modulus of J vector and modulus of K vector. It doesn't have any sign, any direction. All are 1, so this will be equal to 1. And if we will take J vector, one thing you have to remember that J, A dot not U, it is not a dot, this is not a dot. I vector, if we will take, then again we will get 1 And if you like take Aij, Aij, okay, then again we will get 1. So both the triples are equal. This is equal to this, and this is equal to this. It should be remembered. And one necessary and sufficient condition. There are very necessary and sufficient condition. Necessary and a sufficient condition that sufficient condition is that three non-parallel vectors and non-zero vectors also non-parallel and three non-parallel and non-zero vectors. Three non-parallel means they are not parallel or not zero. Non-parallel and non-zero vectors will be coplanar. Will be coplanar if we found that their scalar triple product is zero. Its magnitude zero. Scalar triple product's magnitude is zero. Magnitude is zero. Then the three vectors will be coplanar. Means lies in a common plane. Three vectors. Also, we have to remember that this is any parallelepiped. Parallelepiped is that you can remember this parallelepiped. The diagram of parallelepiped. So this is the just a parallelepiped I have drawn. I hope good one to look. So the volume of the parallelepiped can be measured through scalar triple product. Volume अरे चलो ना equal to the scalar triple product of any three vectors working like this is the A vector, this is the B vector, and this is the C vector. Then we just find out the scalar triple product. We can find out the volume of the parallelepiped. So in this way we can find out the volume of the parallelepiped. Now we study reciprocal vector. What are reciprocal vectors? Reciprocal vectors. Reciprocal vectors are are found out for non-coplanar vectors which does not lie in a common plane. So there are three vectors: A vector, B vector, and C vector, which are non-coplanar, lie in different plane. Three vectors are non-coplanar.
Papa, ini mau. Wait a minute. Papa, 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 I'm going to do. I'm going to do. I do. I do. I do.